we are good to start with the NoSQL database and the Hbase. And in the NoSQL database, what is going to be our focus is basically the Hbase. And so when we'll see the landscape of the NoSQL database, it has multiple database which qualify itself as a NoSQL database. And when we talk about the NoSQL, it has several definition of the NoSQL. Like some people call it like not only SQL, or some call it just NoSQL. There is like no select star kind of a stuff, right? But only thing, right? Whenever you are talking the NoSQL database, all the database has its own differentiator in terms of what kind of the functionality they offer. Only thing common what you will find in all these NoSQL database, that they don't have the SQL interface. So that's the only thing common. Apart from that, you have the multiple NoSQL database, and they all have their own way to access the data, put the data in that, delete the data, and all those stuff. So we'll understand about this, like how we interact with the NoSQL database and how we work with that. Okay, so when we talk about today's world, right? When we talk about the today's world, especially where you have the huge volume of the data, and basically the data is not something which fits exactly in like very normalized kind of the data or the structured data what used to have in last 20-25 years, where majority of the the data which used to come to us, it used to be in the form of the structured database, and we used to normalize all those data, and then we used to store inside our data warehouse. But when the companies like the Google, Facebook, Twitter, they try to scale with all these the web kind of the presence they had, and the kind of the data they were getting, and the main thing in terms of the speed what they were looking for. So to get all the data set which they had, and combine that data set and then present on their site, or the whatever the interface they had, basically the web interface, they faced a lot of challenge in terms of the way we used to store the data. Okay, so that's like the one of the challenge they had, right? So when you talk about any kind of a RDBMS system or the database kind of the system, you have basically like when you go for a RDBMS kind of the setup, what you do is first you get a kind of a cluster machine, you install some kind of the RDBMS software on that, whether it's like MySQL, or you get it from some particular vendor. And then you start using your database, you connect it to your web interface or whatever way, you start inserting the data in your database. And then slowly what happens as your the size of your database starts growing, you start getting the problem in terms of the performance, your the latency start increasing. And at that point, right, what you try to do is you try to put some kind of a caching layer in front of your database, so that you can access it in a faster way. But the caching has its own limitation in terms of how much you can put. And then what you do is you try to basically like try to relax some of the RDBMS the constant what we have, like you try to drop index and try to have like denormalize kind of the tables to avoid certain joins, and those things little bit give you like improvement in terms of the performance or the data what you look from your RDBMS kind of storage. And then also, like if your database performance doesn't increase, then in that case what you do is you start having like pre-computed materialized view, like where you can just write some SQL and you can get the data. Right. So once you travel this particular journey, like starting from setting up a RDBMS kind of the system, adding a caching layer, dropping index, putting denormalized table, having a materialized view, you basically move away from the benefits which RDBMS offers in terms of differential integrity or the indexing or ACID kind of transaction, right? So when a company like Google started basically storing their data, and the data which Google had is basically the data which was coming from the internet. One of the challenge they had is like the way they wanted to use the data cannot be stored in the way how the RDBMS were designed, or the way they were storing the data. So at that point, what happened? Google did a step back kind of the approach, and the approach was like to design something which will be able to meet the need in both the terms. One is like the scalability, because the volume of the data, as well as in terms of the performance, because the data need to be accessed in a particular way where you don't want to have basically the normalized kind of the data. You are okay to have the denormalized data as long as it gives you the performance. So that's where all this whole stuff is started, and Google implemented this whole concept in something called the big table. So like how the whole journey of the Hadoop is started from the Google, where Google published the MapReduce paper, Google file system. So on the same line, Google had the third paper, that's basically the Google big table paper. And that paper, people at the open source community, they took that and they implemented the whole stuff as part of this Apache open source umbrella. And that particular stuff is called something called Hbase, that we are going to focus. Right. So when we talk about Hbase or or the NoSQL database, so as we see here, like the example of the Twitter, right? So okay, I have a comment here. Let me take that. From Pradeep, right? So Pradeep says, okay, Angela Jolie is not a problem. Okay, okay. So yeah. So the thing what we are trying to bring it here is like, if you talk about the Twitter, if you talk about LinkedIn, Facebook, right? All these has the huge volume of the data that need to be basically stored and processed, and it cannot be stored on a single machine or in one particular database. And the data what you store is basically have the changes kind of the schema and as well as the kind of the structure what you store, right? So all those have like similar kind of the challenge which you are dealing with. So, to store all these kind of data which you are getting, right, you need a system which will be able to meet a certain kind of requirement or a certain kind of the characteristic, and based on that, you will be able to basically come up with a solution. So that's where you will see all these companies, most of them are nowadays using this NoSQL database that's able to meet their requirement in terms of the storage, as well as getting the data and coming up with the services based on the way they store the data. Right. So all these examples which we saw here are like be it Twitter, LinkedIn, Facebook, right? So all these have like few things common. They are dealing with a huge set of the data. And although the data is huge, the access pattern what we have is basically they need to quickly access in any kind of the data. Like suppose if you have, if you are talking about the Facebook and you posted some comments maybe last year, or you uploaded some picture a year back, if you want to access that, you should be able to retrieve that data set, right? So your data access pattern is very random. You are not just interested in the recent kind of the data, but you want to go back and access any kind of the data set. Then the data what you have is not only the structured data, but you have the structure, semi-structure, unstructured. So basically the combination of the data which you want to store. Like example of the Facebook, right? When you want to store Facebook, it has the image data, it has the text data, it has semi-structure kind of the data where people embed things, right? So all those kind of the data you want to store in your database, and you want to retrieve that. And one of the thing that is like common across all these the applications which you do, like if you talk about Facebook, Twitter, right? So all these applications, they keep growing, right? So every year you have some new kind of the features, new kind of the interface which is coming to that, right? So whenever you design a backend system for that, you don't have the upfront schema for that particular solution. Like take the example of the Facebook, right? Like suppose if you design the Facebook login page, like what the information Facebook might be capturing 2 years back in terms of the login phase. Today they capture altogether different set of information. Now if you are migrating, like suppose earlier you were capturing like 10 columns, like name, maybe the primary email, the country and all. Now you, along with that, since you are offering multiple service, you ask user like provide the LinkedIn ID or maybe your Twitter handle or some other stuff, right, which you are capturing all this. So you're basically the front end schema change, and you want your backend should be in such a way that if you add 10 more columns in your in your application, your backend should be able to accommodate all those 10 new columns without having too much kind of the overhead in terms of like how to accommodate that. Uh, if you guys have worked on an RDBMS world, you must see, right, suppose if you have in a table and where you have 10 columns, and if you add 5 more columns, you have a huge process. You have to work with your DBA team, get the new table created, then you migrate your existing data to the new table, and then you start using the new table to your application. So it takes a good amount of time to basically get to that particular state. With like Hbase and other NoSQL database, what you will see that like one of the things we'll see that when you create a table, you don't even specify what is the column name and the data type, right? So basically you don't specify any structure, just you tell that, okay, this is my table name, and there's a concept called column family. So you just specify table and the column family name, and you create the table. When you start using that particular table, at that particular point you specify, okay, this is my column and this is my value. Go ahead and insert that. And Hbase has those kind of the flexibility where it will be able to take that request, it will create that column, and it will insert that, right? So that's the kind of the support it has for the schema. So it can support all these variable schema kind of requirement. Okay. So apart from that, what else it has is like the compression, because you are dealing with the huge volume of the data. It has its own compression, the way the files are stored, and you retrieve the data set. So the compression is also inbuilt in all these kind of the requirement which you are dealing with. Okay, and the last thing what we have is since you are dealing with the huge data or the big data kind of the problem, all this data cannot be stored in one particular machine or a single machine. So you have to basically distribute this data across multiple machines. With all this, the NoSQL architecture or the Hbase kind of the architecture, what you will see that is it is having the way the architecture has been, it follows this master and the slave architecture, and you will have automatically your data will be distributed across multiple machines, so that whenever you want to scale it, you have the flexibility, you add more machine, and you can store more data, and you can get the better performance, right? So to meet all these needs, we have all these NoSQL requirement that basically able to provide you solution to some of the problems which are listed here. Apart from that, if you guys able to recall our Hive discussion which we had last week, we just saw that Hive is basically a interface where which is on top of the Hadoop, and by using that Hive interface, what you can do is you can have you can create table, you can insert the data, you can retrieve the data, right? But one of the thing which Hive doesn't offer, and that's very, very common across all this NoSQL world, is basically the ability to perform kind of the update or delete for the data which is stored inside the table, right? So like in case of Hive, you have created a table, and if you want to do some selective delete, like a row which is not needed there, you cannot do that in Hive, because in Hadoop you can only append the file, you cannot go and modify a particular file, right? So that's also like when the people across multiple industry, they starting this Hadoop kind of solution. One of the demand or one of the features they were looking for is to have the support for all these kind of something we call is CRUD operation. So basically the create, read, update, and delete, right? So they wanted to have this kind of the flexibility, because whatever the RDBMS world we had seen earlier, they had basically these functionality where you can selectively tell that, okay, this is the the key, and based on the key you wanted to have the update or delete. So in case of Hbase, what you will see that it supports all these operations. So by using Hbase, now you can go ahead and update a particular record, you can go ahead and delete a particular record, right? You can go ahead and fetch a particular record, right? So those kind of the stuff is now supported with the help of the Hbase implementation on top of Hadoop. Okay, right. So like suppose if you want to build a an application like a LinkedIn kind of application where you have the huge data set, you want to relate all these data, like if you have multiple users who are coming and signing on the LinkedIn, and based on their kind of the information which they provide, the company they work for, the project they work for, right? So based on that, you want to have a kind of a connect of them, right? You want to suggest the people you may know, or may working on the similar kind of project, or or the kind of company. You need to basically analyze the whole data set which you have. So the data set is the huge, right? And then you want to bring the data set together so that you know that, okay, if the two people have the working for the same company, the chances of they may know each other is very high, right? So you basically want to solve all this stuff, right? So now if you go with the normal RDBMS approach, what you can do is you can have one table where you will have the users detail, one table where you will have the the different connection detail, and whenever you want to bring the data set together to your site, you have to basically connect these two tables, and then you get the data, right? In case of the Hbase kind of the table, what you will see that you can have all those data is stored, like a particular user and what all connection that particular user have, all those can be stored together as a single row, and with a single API fetch you can insert the data, update the data, and get the data, right? So those kind of stuff now are possible to do in altogether different way than we have been doing with the help of the relational database kind of the system. Right. So the kind of the challenge or the problem which we saw, the solution for that is one of the thing is it's a huge volume of the data. So it's basically you know uh, you need a distributed database kind of thing where you can store this data, and then you can perform all these update, delete, and insert kind of the operation on this huge volume of the data that is distributed across multiple machines. Okay. Right. So one of the things is this huge volume of the data you are dealing with. So the data is distributed across the multiple machine, and you need this to happen automatically. So you don't want to basically take the overhead in terms of distributing the data and then retrieving the data. So all these things need to be taken care by the system itself, right? Then the second stuff, what you have is the need for having data to be sorted. If you talk about the Hbase, or if you talk about the Google, right, where it has, let me get an example of this one. One of the thing, right, whenever you are trying to understand about any of, as I told, right, when we're talking about the Hive and the Pig, right, so whenever you try to understand any of these Hadoop tool, you have to understand, or Hadoop tools characteristic, you have to understand, like what is the user's pattern, or what's the background it has in terms of having this particular feature. So like if you are talking about all these data, like when you talk about the Hbase, the data in Hbase will be automatically sorted. Now the reason why this data need to be sorted, you can understand with like the simple example, like what the Google need is, like so like if you talk about the Google, right? So Google has whole the internet data which we get in the Google. So like Google has like there is a company called abc.com, right? So Google has all the details related to the abc.com inside their database. So abc.com has multiple the pages, like it can have abc.com, then it can have like something called mail.abc.com, then it can have something I'm just taking like ftp.abc.com, and then you can have some other company as well, like www.abc.com. Now when it comes to the Google, right, it may happen like you have something called like this, right? Your data the Google may have the data something like this way, right? Now when it comes to the, like somebody, if they're looking to, like for this company like abc.com, like suppose if you work for that and you just want to access the email, in the Google, just you are going to do something ABC, right? You're going to search for that. Now, Google need to have a mechanism to identify from this huge volume, like you have, millions of the pages which you have hosted on the internet. From there, it has to fetch out all the pages that relate to the ABC. Now, when you try to do that, one way is like it can display like this way, where the first page is abc.com, then second EBC, and then EBD kind of thing. Now, instead of that, what Google does is Google, whenever you store, or Google, whenever you store anything, they basically store all this kind of information in a very sorted way. So basically, when we talk about the Google, it will store these pages something like this, abc.ww, and these are based on the pattern, like how the people uses these database. abc.mail, then it will be something like com.abc.ftp. Guys, not just basically paying attention in the sorted. All I want to bring you here is like why we need the data to be sorted. So now, if you have store your data in this particular way, where you have the sorted the data, like so, maybe this will come first, right? I think this will come last. Right. So now, if somebody comes and search for ABC, Google can link all these pages together. So it has to okay, com.abc, and this find this all these pages, and based on that, it can list all the first 10 pages that will belong to abc.com. So so this is like one of the requirements. Similarly, if you talk about the Facebook or the LinkedIn, so there also the user details will be sorted internally, so that you can find all the related stuff together. So by default, you will see all these Hbase kind of storage. They have the data that will be sorted. This is like one of the example based on like the real the use case. You will find a lot of the requirement where you want all these data set to be stored together. Then the second stuff, what you have with all these databases, basically the sparse data store. So what the sparse data store is like, if you design a Facebook kind of the application where you put like 100 columns or 100, like if you are getting the information about the profile creation, you have all the set of all a set of questions which you want to ask from the people, but hardly anybody provides all those information. So some may provide you the the location they are or the profession they are working for, but most of them, they may not provide that. But if you design a normal RDBMS kind of solution, what will happen? You have to have basically provision, like where you define each column structure, and you tell that, okay, even though we are going to get the data or not, for each row I'm going to allocate like 10 characters or 20 bytes for basically storing this particular column data. So if you have a lot of null values that you want to store, like one of the column is null, you need to have a mechanism to basically store that in the normal RDBMS world. In case of the Hbase, it uses something called the sparse matrix. So with the help of the sparse matrix, what you can do is, if you have any value is null, you don't need to basically store anything about that particular column or that particular cell. Whenever you are retrieving the data, the null values will get automatically calculated based on the storage pattern which they follow. So basically, all the overhead related to how to handle the nulls in terms of the storage is basically handled very well in terms of the storage sparse storage which it follows. And then you have this automatic sharding. So basically, your data get distributed across multiple machines in a very automatic fashion, so that solves the problem with the horizontal scalability. So as you grow, you add more machines, and basically you will be able to do more read and write operation. Right. So all these basically lead to kind of a solution, and that basically gives a kind of opportunity to have come up with a multiple kind of the implementation that will be able to meet these challenges in terms of the distributed database, sorting the data, handling the null values, and having the automatic sharding in terms of horizontal scalability, and by adding the more machines. So when it comes to the solution, right, you don't have just Hbase as like one of the only the database which offers this, but it's basically gives you the landscape of this particular slide. What it gives you is like the complete landscape of the NoSQL database. So you have the multiple database that qualify itself as the NoSQL database. Like you have DynamoDB, you have the Bigtable, Cassandra, MongoDB, you have all these FlockDB, Neo4j, right? So all these databases qualify themselves as the NoSQL database. And only thing you will find common across all these databases, like they don't have the SQL interface, right? So apart from that, what you have is like all these NoSQL database, although all of them are having a similar kind of the problem which they try to solve with the huge volume of the data, and the different kind of the data they store. But based on their characteristic, they are basically categorized in all these 4 categories which you see on your screen. So one is called key value store. You're going to understand what's there. Then you have the Bigtable clone. So basically the kind of the database design which are influenced by the Google Bigtable paper. So all those kind of things it calls Bigtable clones. Then you have the document database. Like if you have your data in like JSON format, XML format, and if you want to store that and analyze that, so those are like in the document database you have. Then if you have the requirement of having the graph database where you want to link the different kind of the data elements which you have, and you want to analyze in the node and edges kind of the format, so those comes in the graph database. So all these the implementation, they differ in terms of or how they are implemented, or on what kind of the problem they try to solve. Like if you talk about the key value store, where you store the data based on the key, and you fetch the database all the value of the of a particular record based on that particular key, right? So they are called basically the key value store, something similar what we have in the Hbase as well. So in the key value store, you have something like DynamoDB. So that's a kind of the offering from Amazon. So it's a kind of Amazon cloud offering, and they offer it as kind of a database as a service. So it's a kind of a simple, cost-effective kind of the way to store the data and retrieve the large amount of the data on the clouds, right? So that's like their primary database which they offer as the NoSQL database on the cloud. Similar way, you have Walmart. That's again used by the LinkedIn, and it's again a key value store you have. And if you guys are kind of the Harry Potter fan, right? So you must be able to relate it with the the famous villain in that, right? So that's kind of the name it has, and it's used at the LinkedIn. Then you have all these like React and the Tokyo cabinet. So they are basically again influenced somewhere by the Amazon Dynamo paper. Like React is basically implemented on the same principle of the Amazon Dynamo paper. And you have a lot of good use case for using this one, like Best Buy and AOL. They uses that, and basically it's for their fault tolerance and kind of the support they provide. And the interesting thing is DynamoDB is basically from Amazon, but this React and all, it's free, right? So you can just go ahead and use that to meet a similar kind of requirement. Tokyo cabinet, again, it's a kind of the key value store, and you have like delete, retrieve, all these things you can do based on the key value stuff. And only thing is, this whole stuff is implemented in C++, so you have different kind of the performance benefit with using that. So that's all like the key value store kind of implementation of the Hbase database, and that's basically comes the influence mainly from this Amazon DynamoDB. Then the second category which you have is a Bigtable clone. So that's again from the Bigtable, or the the Google Bigtable paper which we had. So it's again has the concept of this row key, and the based on the row key you fetch and insert the data. So all these Google applications which you see like YouTube, Gmail, Blogger, right, .com, right, all those things are powered by having this the Bigtable kind of implementation. So similar to Bigtable and the key value store, what you have, so basically the combination of these two things is something called the Cassandra, right? So it was developed, the Cassandra was developed at the Facebook, and the one of the author, right, who basically developed this particular stuff, he was also part of the Amazon DynamoDB project. So basically you will find The Cassandra is a combination of both the Amazon DynamoDB and the Bigtable concept, Hbase concept. Right. So that's there, right? So then you have the Hbase and Hypertable, right? So these are again the Hbase is like what we are going to focus today. So it's based on again the Google Bigtable paper, and there are like multiple the definition for the Hbase. It's called as the Hadoop database. Some people call it key value store. Some people call it column family oriented database, right? Some people call it like database with having version kind of different versions you can store the for a particular value, right? So all those kind of features it has. Similarly, you have this document database. So document database is again like where if you are dealing with a lot of JSON and XML file, and if you are not having a very flexible, or you don't want to adhere to a schema, you can basically go for this less rigid kind of the database. So like MongoDB is like one of the again popular. So it's implemented completely in C++, and it's used by the eWay, and it's very well supported for all these the document database which we have. Then you have the graph database, so where you want to basically analyze your data in terms of the node and edges kind of thing. You can use that. So one of the example is the FlockDB. That's again from the Twitter. So it's basically gives you the opportunity to analyze your data by linking the data together, and then seeing the the pattern common across between the different node and the edges. So as you can see here, the NoSQL database, it has a huge landscape which you can see, and you have the multiple kind of the offering of the NoSQL database. And I'm not sure which kind of thing your project or your requirement is, but like nowadays you have the multiple use case where people go for Hbase, Cassandra, MongoDB, right? The Amazon DynamoDB. So there are the implementation for all these kind of database we have. But right as part of this particular class, what we are going to focus, we are going to basically focus mainly on the Hbase, how to deal with the Hbase. That's what we are going to learn. Okay. So as I told, right, so Hbase has multiple definitions. So it's something called a Hadoop distributed database. It is basically offer you consistency, sorted data which it stores, it disperses, that it handles the null and across the multiple machine, right? Okay. So now let's get started with Hbase, because something which we want to focus as part of this class, and in terms of our understanding about the NoSQL database will be the Hbase. So as I told, right, Hbase is called the Hadoop database, and some people call it as a key value database as well. So basically, whatever way you understand, fundamentally it's a kind of the platform for storing and the retrieving the data. And when it comes to storing and retrieving the data, one of the key things which you have different than other stuff what we learned, Hive and all, is basically it provides you the flexibility of the accessing the data randomly. Means you can write the data based on particular key, update the data, delete the data. So that kind of the flexibility it offers you. And in terms of the the growth of the Hbase, as you can see, so the whole journey of the Hbase is started somewhere in 2006. That's with the Google Bigtable paper, and then in 2007 it becomes a Hadoop project and the sub project. So like that way, and you have nowadays multiple release of the Hbase. So you see here 0.92 release in 2011. Nowadays you have 0.96 and 98 kind of the release. So it's a very recent kind of the technology which you have, and you guys are learning. Although we are talking about the Hbase, there are a lot of the bug fix, a lot of improvement in terms of the challenges which we have in Hbase is going on, guys. And what you will find is it's very interesting to learn about all this stuff, because if you talk about few years back, nobody was talking about all this NoSQL database. Everybody was very comfortable with using SQL kind of an interface, but last 3-4 years, right, the people to meet the need in terms of the volume and the speed, everybody is moving from SQL to the NoSQL database, and that's where you will see that Hbase like being one of the offering there, since it's free and it basically works on the similar kind of underlying architecture. That's basically the Hadoop architecture. So we'll see about the Hbase architecture as well, how it stores the data and all. Right. So when you talk about the Hbase and the normal RDBMS, so there are certain difference which we need to understand. So when you talk about RDBMS, it stores the data row-oriented form. So what it means that each row will be stored. All the columns for a row will be stored together. When you talk about the Hbase, it's basically the column-oriented. So all the value for a particular column will be stored together. In case of the RDBMS, what you have is you have a flexible fixed schema. So whenever you want to create a table, you first define the schema, like how many columns you want, and based on that, you go ahead and design your solution. In case of Hbase, what you will see is the flexible schema. So you can add the columns on the fly. What it means is, like, whenever you're inserting the data at that particular time, you will tell, okay, this is my column name and this is my value. Go ahead and add that, and Hbase will be able to do that. If you talk about this thing in the normal SQL world, it cannot happen. But in terms of the NoSQL, the Hbase, this is something which is possible. Right. So again, since Hbase, I told it handles the null value, the storage, it uses the sparse matrix, so it's able to handle all these the fields which are null very gracefully. You don't need to basically have any kind of the overhead in terms of the storing and retrieving all those columns which are null. But in case of the RDBMS, it is not optimized for that. So you see some kind of the performance hit when it comes, like the column has a lot of null values. Right. So that's again Hbase, you can handle that. And when it comes to the RDBMS, they are basically designed with having support the join, right? So all these research or all these innovation you see in the RDBMS, like how fast a join can happen in the RDBMS, that's basically the key USP you have for the that particular database. In case of Hbase, you will see that it's not designed for the join, so you don't have the join. It offers you, in fact, instead of the join, it offers you to store the data in denormalized way. So you stored all the columns which you need together, and you can retrieve that. So it's not something where you need a lot of the join. You can go with Hbase. But in case if you need join, as we saw in the MapReduce advanced MapReduce class, you can do the joins, because since underlying architecture is Hadoop, so you can still do the joins with the help of the MapReduce, but not very flexible or easier compared to what you have in RDBMS. So in case of the Hbase, it has very tight integration with the MapReduce. So you can, since it's offering on top of Hadoop, so you can always use all this MapReduce concept on top of this storage. But in case of RDBMS, you don't have any such concept like the MapReduce way of processing. In case of the Hbase, you have this horizontal scalability. So whenever you want to grow the size of the data or the processing, right, you can add more machine, and your whole whole infrastructure can scale based on the number of the machine which you had. In case of the RDBMS, it's very hard to basically scale, because if you want to scale up your database, you have to work with the vendor, get more machine, and basically wait for the next release, and based on that you go for that. So kind of the usage pattern between RDBMS and Hbase, if you have your structured data, RDBMS may be a good kind of the solution for that. But if you are dealing with a lot of semi-structured data, unstructured data, or other structured data, right? So all different kind of the data set you are dealing with. So in that case, Hbase may be a good example to basically go for. Right. So when to use Hbase? So one of the thing is, like, when you are dealing with all kind of the data structure and structured data, you can go with Hbase. When you have the high volume of the data that to be stored, so again Hbase may be like one of the solution, because it has this horizontal scalability. If you want to have the column-oriented data, right, where you want to retrieve all the columns together, right? So like suppose if you want to find how many people are from a particular geo or particular country, right? So where you want to analyze the data based on the column, you can do that. Another thing what you have is the version data, right? So when you want to store the multiple version of the data together, you can store that easily with the Hbase. If you go with the normal RDBMS, like suppose if take the example of like your password, right? Suppose if you want to store like your current password as well as last two old password as well, maybe for the security reason or whatever purpose kind of thing. If you go with a normal RDBMS table, at one point you can store only one value in a particular column. In case of the Hbase, what you will see that each column you can store basically three versions of the data. So current, prior to that, and prior to that, right? So all these three versions of the data you can store and you can retrieve from for a particular column or the cell. And even you can increase that more than three also if you want, you can do that. So it can store multiple version of the data in the same row. High scalability because it basically grows as you add more machines. It can store the more data, so it is scalability also good, right? And all this data set, everything is underlying architecture is Hadoop. So if you want to integrate it with your existing MapReduce flow, you can easily do with the help of this Hbase and the MapReduce integration, right? So these are the the common use case where you should be looking for Hbase kind of the solution. Okay. So when not to use Hbase, right? So although we are talking about the Hbase, so at like certain scenario, right? Hbase is basically a kind of a solution which provides you this horizontal scalability and kind of the storage of the huge volume of the data. But if you are dealing with just a small data set or few thousand or million of the rows, going with a Hbase may not be a kind of optimal solution because the overhead in terms of maintaining the cluster, storing itself may be too much, right? And another stuff is like if you are looking for a SQL kind of interface, like if you are looking at database, you create a table. In Hbase also you create a table. But if you want to access your data with a SQL kind of the capability as we had in Hive and other stuff, right, where you want to write select star and do that, in Hbase you cannot do that because Hbase doesn't have the SQL interface. Nowadays, there are some, the projects which are trying to provide that interface, guys. But then again, it has the limited kind of the capability as well as the latency involved in that. And when you have the, very small kind of the cluster, like less than 5 node or a small like 3-4 node cluster, and where the replication factor is 3. So in those cases, again, your data will be stored on the same machine, so you will not be able to get the performance. So if you are dealing, so overall, if you are dealing with a small volume of the data, a small cluster, and if you are looking for a a SQL kind of interface, then Hbase is not a solution. Like in terms of the capability, Hbase you can run on a single laptop as well, as you will see, right? On virtual machine you can run that, but then it's just for the development purpose, not something as a machine you can use that. Okay. So there are, the multiple use cases like Facebook uses this for their messaging system. So it's a kind of able to handle this. Right. So Hbase, it is a scalable, robust kind of a solution, distributed, column-oriented, real-time supports, right? So it needs the real-time need, right? Key value kind of thing, you can store and retrieve the data based on the key. Open source project, and basically it has a linear kind of growth. You add more machine and your performance increases. So not only the Facebook one of the users, so you name any big kind of especially all this web company or any huge volume of data, they are using all these implementation which can handle this data, like Twitter, Facebook, Yahoo, Trend Micro, right? So all those have this the Hbase kind of solution, and they are able to use this Hbase to meet their real-time data storage and the analytics. Like suppose if you have a site where as soon as the user is seeing a particular page, you want to basically analyze that and feed certain content. So all those kind of the solution you can build with the help of the Hbase. Okay. Okay. So before I go and more about the Hbase, guys, are you guys able to get the understanding about the Hbase? What kind of the database it has? So what the key feature of the Hbase we have? So now Okay, so now there is two approach, guys. We can take it, right? So basically, one way is to since we are talking about the HBase, right? So one is like we have a couple of slides which will basically show you the schema or how the HBase is stored. Uh, that's the one way to basically take that. Other way, what I find generally effective is if you start seeing the HBase, how it looks like, how we create the table, and then you come back to the slides, then it make more sense to understand basically what is the row key, what is the column family, what is the column family, what is the column name and the value, right? Okay, demo first. Okay, so let me get the HBase machine here.